Alright guys, so what we're going to do on the lab Wednesday and Thursday is we're going to try to determine the formula of a hydrate. When you're trying to determine the formula of a hydrate, it's really just an empirical formula problem. So how many waters are attached to each ionic compound? And so these always come in a whole number ratio. Once in a while they can be in halves, but usually it's in whole number ratio. So anywhere from 1 to 10 water molecules that are attached to the ionic compound. So for example, if you have magnesium sulfate, maybe there's 5 waters attached to every magnesium sulfate. Now the bond between the water and the ionic compound, and there's some debate as to whether it's really a bond, that's weaker than the bond between the hydrogens and oxygens within the water, or the bonds usually between the positive and negative ion on the ionic compound. So if we heat this stuff, what will happen is the water will get broken loose, I don't know, so not a grammar teacher, but anyway, that will break loose and will leave, and if we heat this enough, what we can do is drive this off. So here's some of the equipment that we'll need. You need to have a Bunsen burner because it takes a good amount of heat to separate them, but not a crazy amount of heat to separate them. And then you'll need a ring stand. You're going to need a ring. You're going to need what's called a crucible, and these can be porcelain, or this one happens to be metal. Insert a little cup that you put stuff in. It'll take a high amount of heat. And then on the ring, instead of using a wire mesh like we would normally use, we use this thing which is called a clay triangle. So the way this is designed is you can take this little guy right here, you can put your sample of the hydrated ionic compound, which we've weighed very carefully, and then you should be able to heat this up and determine what the formula for this is. So like how many waters are actually attached to each ionic compound. A few things about this. Students get error a lot because they don't clean out the crucible properly. And then the second part is when they're done cleaning it, and you just use soap and water to clean it out, they don't dry it properly. If you just towel dry your equipment, it's usually not dry enough because you're going to put a lot of heat on there and there's a little extra moisture that drives off there. And then you say those are water molecules when it was just some moisture left on there from your washing process. So what you should really do is you get this thing clean, and then you're going to kind of heat dry it over the Bunsen burner. Also, you start using these forceps right here. Okay, so these are crucible tongs, and they're specifically designed to pick these things up. And then sometimes we can slide it under this way. And I might need 2 hands on that one. And this is designed to grab it that way as well, so then you can go set the stuff on the scale. 2 reasons for that. One is these things get really hot, and that's a little bit problematic. But the second reason is when students are grabbing stuff, they handle it and everything else. We're trying to get really precise numbers, and when you start handling equipment that you're going to put on a scale, the oil from your fingers actually will make this heavier, and our scales are sensitive enough to pick that up. So it's bad lab technique. So that's your first little video on what we're going to do for the lab. And there's an equipment list in terms of what we're going to do. I'll reveal the salt tomorrow or when you come into lab, so you'll have an idea what we're dealing with there. Okay, now, once we've once we've taken the mass of our compound, put it in the thing, we've heated it enough, and the way you're going to know if it's actually dry, because you can't tell by looking at it, so it's going to be chemically dry, is you heat it, take your mass, reheat it, and once the mass doesn't change more than, say, 0.01 or 0.02 grams, we can feel pretty good about we've got it completely dry. So now, we had the mass of this before. It's going to be lighter. The loss of mass was the water that was actually lost. Now how do we calculate what the formula of this hydrate is? And that's the other video.